So on the previous slide, we had the title HR diagram, and there's a video there. So I hope you watched that. And what I want you to realize, maybe rewatch it again, is that basically that's a actual cluster of stars, and they're actually moving them around according to how bright they are and how hot they are. And when you shuffle them around, that's the pattern you get. And this is what we call a HR diagram. So there's like some really great like animations of this out there, and you can go have a look at that High School Physics Explained video if you want. But there's also really great stuff at NASA and other organisations which have that use HR diagrams, and there's really good information. It's worth going through it. This was a really big section in the HSC, like when they used to do like the astronomy elective or astrophysics elective. We don't cover it in quite as much detail anymore, which is a bit of a shame because it's quite fun. Okay, so what I want to do now is I actually want to have a look at the axes of the Hertzsprung-Russell diagram. So basically, what we've got here, if you have a look at the picture, we are looking at the y-axis. And on one axis, you've got luminosity, and on the other one, you've got absolute magnitude. So these are basically just measurements of how bright the star is. And if a star's at the very top, it's going to be very bright, and if it's at the bottom, it's going to be very dull. So how do we measure those things? So if you look at a star from Earth, it could be bright because it is just actually inherently bright. It might be like a very big star. It might be burning very hot, or it could just be really close. So there's a few reasons why a star can look bright. And we call the brightness of a star from Earth, we call that its apparent magnitude, because it appears to have a brightness of whatever magnitude. So that's not that useful to us because, like I said, it could be just because it's close, or it could be to do with it, like other factors. So what we do instead is we use absolute magnitude. Absolute magnitude is just, we do some funky maths and we say, well, if that star was at 10 parsecs from Earth, this is how bright it would look. This is what its apparent magnitude would be. So that's the absolute magnitude. It's how bright it would be at 10 parsecs. And then we can compare stars. If we know that they've all got, particular absolute magnitudes, we can say that, one is brighter than the other. And this is an inverse logarithmic scale. So what that means is a big negative number means that it's much brighter than a big positive number. So a -5 is much bigger than like a +10. All right, so that's one of our axes there, and the other one is luminosity. And that's just basically, it's a measure of the absolute amount of energy that star is giving off. So obviously those things are going to be related. So once again, the really important thing here is that the very bright stars are at the top and the very dull stars are at the bottom.